Its cabin can be a helicopter pad. Its wind turbine rotor is over 40 stories high. When it's in operation, it doesn't need any fuel, and it won't cause any pollution. In its 20 years of designed lifespan, it will obtain 400 million kilowatts of electricity from the air. This all hinges on it successfully being made and its ability to take on the test of nature. This is the giant of wind turbines. Manufacturing it alone has presented all sorts of problems. Installing it during typhoon season on the tumultuous sea will be an unprecedented challenge. On the 2nd of August 2011, on the Sea of Hangzhou Bay, Shanghai, an enormous shadow appeared. This was China's biggest double floating crane, the Fengfan. 38 nautical miles out, on Yung-Chun Island, China's largest self-propelled crawler crane has been waiting for a long time. Together, they would be challenging an unprecedented installation. Zheng Xijie, the operator for China's largest crawler crane. This is a self-propelled crawler crane that is worth as much as a Boeing 737. Its 9,000 horsepower engine can send 800 household vehicles up to 40 stories in one go. Despite his confidence in the crane, Zheng was still feeling a little nervous about this upcoming challenge. Zheng's crane and the Fengfan would be installing the world's biggest wind turbine, the SL5000, in the waters of Hangzhou Bay during typhoon season. The roiling waters and unpredictable ocean wind would be the biggest enemies of this challenge. Since the Industrial Revolution, the accelerating trend of dwindling petroleum and coal resources has become increasingly obvious. At the rate that it is going, these non-renewable energy resources will soon be depleted. The anxiety over energy depletion has already spread. Today, developing applicable technology for renewable energy is a priority for mankind. And this demand is particularly high in China, where the economy is under rapid progress. In 2009, the Chinese started to develop the highly difficult offshore wind power near Shanghai. A year later, the biggest offshore wind power plant in Asia appeared to the east of Donghai Bridge and successfully connected to the grid to generate power before the Shanghai World Expo. However, the ambition of the Chinese didn't stop there. In the summer of 2010, energy engineers began plans to install the SL5000, the world's largest offshore wind turbine, on the other side of Donghai Bridge. The SL5000 has an enormous body. The top of its engine room can be used as a helicopter landing pad, and its wind turbine rotor has a diameter of 128 meters. Such an enormous size would present an unprecedented challenge for the engineering team, both in manufacturing and installation. According to their plans, the various components for the SL5000 would be produced in different provinces in China and finally transported to the installation base near Yangshan Port, Shanghai, for assembly. August 5th, 2011, the installation base on land for SL5000. The freighter transporting the engine room and the semi-submersible for transporting the SL5000 have arrived at the same time. Based on the information from the meteorology department, the 9th typhoon of 2011, Meihua, had turned into a super typhoon 2 days before and was heading in this direction. They must transfer the engine room somewhere safe as soon as possible, while getting the semi-submersible into harbor. To ensure the safety of the gigantic SL-5000 in the transportation process, the engineering team chose to use a bigger semi-submersible than usual. But this decision caused the size of the harbor to become a problem. 2 months before, the harbor was completely revamped for this purpose. Now it could just manage to fit in the semi-submersible. On the other end of the worksite, the engine room remained where it was. At that moment, the weather was deteriorating fast.
Are the handles up? The handles are up.
Jung assessed the wind situation and activated the 9,000 horsepower engine. Lifting the over 300-ton engine room to transfer it to the railcar isn't difficult for the experienced Jung. But the wind by the sea has already left a deep impression on him. He can't help but be worried about the upcoming official assembly and installation. Let's go back to early 2011. After half a year of intense collaboration between various departments, the design for the giant of wind turbines, the SL-5000, was finally complete. Soon, the leading companies in the wind power industry together accepted the challenge of manufacturing this giant. To create SL-5000, the first key component to be produced was the mainframe. The torsion from the wind places the weight of the entire turbine there, so the main frame must be invincible. To manufacture the large-scale extra-thick steel boards, this heavy-duty cutting machine was necessary.
This flames over 3,000 degrees Celsius. Cuts through steel boards like tofu.
Cutting through steel boards 3 floors thick is not this cutting machine's greatest strength. It can precisely cut out any shape designed by the computer. Its precise control over any discrepancy in the cutting process laid a good foundation for the welding to come. The SL-5000's main frame must be able to support the enormous torque created by the longest wind vane in the world. The quality of the welding must be strictly examined. The greatest threat to the welding quality was the residual air bubbles at the welding points. Any excessive air bubbles would greatly weaken the mainframe, causing disastrous results. This is an ultrasound detector. It is used to examine the interior of metal objects. In order to ensure the quality of the main frame, the detector is tuned to the most sensitive setting.
Look, there's an air bubble here, an echo. That shows there's a flaw in the welding bead. When we decrease it by 12 decibels, the flaw becomes very small. The echo is very small, so this passes examination.
All the welding points of the SL-5000's main frame must pass an examination process to ensure it can support the wind turbine, faced with various difficulties in the natural environment. In creating the biggest wind turbine in history, the completion of the main frame was only the start of this difficult task. More difficult challenges lay ahead. To power the large-scale power generator inside SL-5000, wind vanes of unprecedented dimensions were designed. But could they be made? The biggest wind vane manufacturer in China took on this challenge.
Sixty-two-meter wind vanes. We've never manufactured this before, and there's no past cases to refer to. We can only rely on theoretical calculations.
No matter the specifications and shape of the vanes, we must meet 2 basic requirements: the greatest strength and the smallest weight. Yet these just happen to be 2 conflicting requirements. Like all design engineers in the manufacturing industry, project manager Dr. Liu Yong must find a balance between these two requirements. Abnormally strong wind is something wind turbines often face. If the wind vanes are subpar, the result will be disastrous. The wind vanes for the SL5000 were the biggest, longest wind vanes currently in commercial use in the world. This meant the strain it would be under would also be the greatest. What material could be used to make the vanes to satisfy the demanding conditions? In the end, the scientists managed to find the ideal material, epoxy resin. After solidification, this material is extremely stable, both chemically and physically. Its only weakness is its tensile strength, which means it is too brittle. However, like adding cement to reinforce steel, scientists added certain braiding to the epoxy resin to create a compound material. This compound material was what we usually call fiber-reinforced plastic, or FRP. How would this aided braiding change the property of the resin? It's only a quarter of its original thickness and weight, but it is more than 10 times stronger. Seems like FRP was the best material for making SL5000 wind vanes. Wind vanes for wind turbines come in irregular shapes. Only then can they perform to their best in terms of aerodynamics. However, the irregular shape, added to the extremely large size, has made two difficult factors that make manufacturing exponentially more difficult. The most reliable way to confirm if the manufacturing met the design requirements would be to manufacture a wind vane sample for testing as soon as possible. Six months later, with the help of computers, a wind vane sample was successfully manufactured. However, was it the perfect wind vane everyone was expecting? The eastern coastal area, centered around Shanghai, is one of the fastest growing regions economically in China. With such rapid economic development, there is great pressure on energy supply. Constructing a large-scale power plant that uses fossil fuel, however, would cause serious environmental problems. Today, clean energy with much advancement in technology provides an alternative in resolving this dilemma. Yung-Chun Islands used to be a cluster of deserted islands on Hangzhou Bay to the south of Shanghai. Since 2005, this has been made into a large-scale seaport. When the over 30-kilometer-long Hangzhou Bay Bridge connected to the mainland, Yung-Chun Port was transformed into a world-class deep-water cargo port. As Yung-Chun Port was being effectively developed, people also noticed another abundant resource there, the sea wind. The wind here could reach up to 300 watts per square meter, and for persistent periods of time. With such excellent wind resources and such proximity to where energy was being expended, Hangzhou Bay seemed like the ideal site to build a wind power plant. However, this is also within the affected area of the West Pacific monsoon. For several months each year, it is ravaged by typhoons. Installing supersized wind turbines here meant more than just the challenge of wind and rainstorms. Any overlooked factor could create disastrous results when faced with such harsh conditions. The quality of the wind vanes was vital. The largest wind vane testing center in China conducted the strictest tests on the wind vane sample. Would all the efforts poured in prove to be futile? Could the sea giant, the SL5000, be born as scheduled? It all depended on the test results. How could any minuscule change be detected in the process of the wind vane testing? The answer was here. Before testing started, project manager Dr. Liu stuck on stress sensors on various parts of the wind vane. During the testing process, the tiniest damage to any point on the wind vane would be detected by the computer through the stress sensors and recorded. The laboratory would be testing the wind vane with an imitation of nature's strongest force. When the red light came on at the door, no one could enter the site.
Over a standard 20-year lifespan for a wind vane, it experiences about 4 million oscillations. In our process, under the same load, we subjected 5 million.
To ensure there would be no problems in actual operations, Dr. Liu increased the standards for every experiment.
Now the wind vane has been oscillating for 6 straight days. It's at about 250,000 oscillations and will end when it reaches 5 million.
4 months went by. After a complete set of tests, the wind vane would have been subjected to an equivalent of 20 years of extremely harsh natural conditions. It is time to check for any internal damage. From the results of the examination, the vane's internal structure appears to be in perfect condition. Dr. Liu's hard work these few months have not gone to waste. 3 days after the testing came through, the first SL5000 wind vane was demolded. August 30th, 2011, Yung-Chun Island. Site manager and engineer Mr. Chu was in a particularly good mood. The 5-megawatt wind turbine and the SL5000 wind vanes were finally delivered the day before. Due to uncontrollable factors such as the weather, the installation progress of the SL5000 was already far behind schedule and was almost past the leeway afforded by the set schedule. Currently, the equipment rent and staff cost every day come close to $100,000. If they could start assembling work today, the over-budget issue wouldn't be too serious. What Mr. Chu longed for even more was 2 weeks of vacation back home in Beijing, once the final assembly work was complete. After living on the work site by the sea for almost half a year, Mr. Chu felt like his entire body was rusting. Assembling the wind turbine started with the wind vanes. There was only one priority here, to ensure the wind vanes don't bump into anything. Any internal damage caused by the slightest jostle could develop into a major flaw as time went on, rendering the vane unusable. The team tasked with this job was the most experienced professional offshore wind turbine installation team in China. However, soon after the installation started, they ran into difficulties. Faced with such enormous vanes for the very first time, following previous procedures might present certain risks. No one dares to be careless. The experienced installation chief has suggested a non-standard solution after meticulous research.
Do the specs meet
This doesn't meet standard protocol.
The protocol is right.
This many holes. If I take this angle and at this point it almost meets the ground, I can go back. What is the influence?
As site manager, one must assess sudden situations quickly and make decisions accordingly. Faced with such enormous wind vanes with no past experience to draw on directly, after brief consideration, Mr. Chu agreed to employ the new installation method. The new installation method worked. The 3 wind vanes were smoothly installed. The rotor of the Sea Giant SL5000 presented itself for the first time. The infinite power of wind is nature's gift to us. It is green energy that will never run out. On this front, humans continuously issue new challenges to the application and difficulties of wind power technology. On the Chinese market, a 5-megawatt wind turbine could obtain electrical power worth over 400 million renminbi from thin air without expending any energy. However, the prerequisite to these benefits is that the SL5000 could hold on for 20 years or more at sea with harsh natural conditions. In case major components, such as the bearings, need to be replaced while it is in operation, the hope for profit will be gone. Bearings have to withstand force and be in action, and are thus the easiest to be damaged. The bearing that the SL5000 needs will be the most difficult to make in the history of bearing manufacture. To date, only 3 factories in the world have the capability to take on this challenge. On the map of China, Huafangdian is a county-level city that can barely be called a city. There are 2 mysterious machines here. They are the most powerful and precise monster machines that mankind has currently made. Their existence has given humans enough confidence to face the difficulties met with making the SL5000. In layman terms, a bearing is a circular, high-speed, closed orbit. Its every detail must be extremely smooth and even. A precise bearing has very strict standards on smoothness and evenness. As dimensions increase, the difficulty in ensuring these precise standards are met also increases exponentially. Giant wind turbines like the SL5000 require an enormous bearing for support. And in fact, this bearing was a precise bearing with the largest dimensions in the history of bearing manufacture. To make this, the most advanced processing equipment currently must be used. First up was this heavy-duty milling machine. This is the most precise large-scale metal component processing equipment in the world. It has 2 unique functions. First, it cuts through metal like water. Second, it can process components over 3 meters in diameter with a margin of error in microns. The material used for the bearing is 5 times as hard as a stainless steel cleaver like the one used at home. And this machine only takes 45 seconds to cut a deep trough in this material. It has been 3 hours. The components of one bearing have been processed. As the bearing rotates at high speed, any minuscule flaw could be exasperated rapidly. The bearings must be tested. Traditional testing methods on what could cause serious damage to bearings are no longer good enough. It was time to bring out another monster machine. This is the world's largest 3D precision detector. To ensure all detector sensors are hard enough and that detection standards are at the micrometer precision, all its detector sensors are made of expensive rubies. The detection range of this detector exceeds 3 meters, with a detection precision of up to 0.8 micrometers. To use a more visual metaphor, on a completely flat piece of land 3 kilometers in diameter, if anywhere there was a protrusion the height of a grain of sand, the detector would find it. The SL5000's main bearing has a diameter of over 3 meters. But the margin of error in the processing of this huge bearing must not exceed 6 micrometers.
How can we visualize 6 microns? It's actually approximately a 20th of a strand of human hair.
With such powerful equipment, all the bearings of the SL5000 were finally manufactured. Among them, the biggest bearing was 2 stories high. It was to be installed at the base of the engine room. With it, the sea giant SL5000 would be able to turn as it pleases in the direction of the wind. Alternating current, AC, is an electric current where the voltage and direction of current flow undergoes cyclical changes. It is one of the greatest human inventions made over 130 years ago. However, when AC was just invented, no one understood what it meant for the future of humankind. The great inventor, Thomas Edison, was strongly against AC. To this end, he employed various tactics and even gave his assistant silent approval to electrocute an elephant to death so he could prove the danger of this current. Today, Edison's experiment just seemed to indicate the power of AC. As the advantages of AC were discovered one by one, humankind rapidly entered an age of electric power. Today, human life is intertwined with AC. AC has become the basic force empowering our society. Due to this, we continuously look for different ways to satisfy the demand for this energy. The burning of fossil fuel to obtain energy is the most convenient option. But non-renewable fossil fuel will be depleted sooner or later. And pollutants released from the burning of fossil fuel has been proven to be the culprit behind many ecological disasters. As technology advanced, mankind gradually mastered various ways to obtain clean energy. From hydropower, nuclear power to wind power and solar power and more. However, to date, none of these alternatives have been proven yet to be the perfect solution. Of all the clean energy currently explored and in use, wind power has, as far as we know, the least impact on the environment.
Raise the anemometer.
All right. Is that high enough?
Raise the wind tower.
Wind power doesn't cause any pollution, will never run out, and is abundant. At a rough estimate, the total capacity of wind power in the world is 3 times that of the world's total energy consumption, which means if we could make full use of all wind power, it could power 3 Earths. Yet the reason wind power can't become the major source of energy lies in how arbitrary the wind is. The arbitrariness of wind is an inherent flaw in wind power. Intermittent power cannot be directly used by humans in life and production. The biggest feature of usable energy sources is that power generation and consumption occur simultaneously. The goal of a power grid is to maintain as much as possible a balance between power generation and consumption. Because an imbalance causes not only power wastage, but on a more disastrous level, the collapse of the power grid. The intermittence in wind power, which cannot be overcome, would certainly exacerbate the imbalance between power generation and consumption. Without adequate regulating ability from the grid, a major push for wind power could only remain empty talk. Nowadays, cutting-edge technology such as high-voltage DC technology and AI power grid systems have already equipped China's national power grid with powerful regulating capabilities, opening up a bright future for the application of wind power and other renewable, clean energy sources. The SL5000 would be given a huge stage on which to shine as well. In July 2011, almost a year after design and manufacturing work commenced on the SL5000, the mainframe, transmission, power generator, and other major components had all been installed into the engine room and tested. The SL5000's engine room was finally ready to be launched.
Right there!
The SL5000's engine room was finally ready to be launched. It was then loaded according to plan. The drive out of the factory was a smooth one. The flatbed truck, transferred from over 400 kilometers away, may look ordinary, but it has special functions. Every set of its wheels can be controlled independently. Three hours later, the SL5000 reached its final destination on land. The freighter waiting here will transport it to its final site of installation, Yangshan Port. Installing wind turbines at sea is an extremely dangerous engineering challenge. On the Sea of Hangzhou Bay, the difficulty of this challenge is exponentially higher.
The current here is rather fast. It's close to Hangzhou Bay, so the current here is relatively faster than most places.
The biggest enemies when working at sea come from the wind, waves, and unpredictable weather. Sometimes, the sky may be sunny and clear, but it is another story at sea. The danger of transferring from the ship to the platform lies in the movement of the ship on the waves, while the platform is fixed and steady. On the open sea, this problem is exasperated. In preparation for the coming, final, and most difficult challenge, the offshore hoist and installation, monitoring of the hoisting site, became even more frequent. The SL5000, to be hoisted near here, was the largest offshore wind turbine in the world to date. It is over 150 meters in height and 400 tons in weight. If the impact of the waves and wind caused an object of this weight to collide with the fixed platform during the installation process, even the slightest collision could result in unsalvageable consequences. The challenges presented with installing the SL5000 seem to be extraordinary. On the 3rd of September 2011, on Yung-Chun Island, the most important procedure in the installation of the SL5000 began. The key step in the installation of a wind turbine lies in the assembly of the wind rotor and engine room. Before that, the engine room must be fixed to a temporary tower top at a pre-calculated angle. Thanks to comprehensive planning and meticulous operation, the enormous engine room was put precisely in its premeditated position. The installation of the engine room demonstrated a good start. It was time to transfer the wind rotor on the square. The transfer process for the rotor contained great hidden danger. Because the SL5000's wind rotor was not only big and heavy, it was, more crucially, of a unique shape. Only 2 cranes could be used to lift it horizontally. The difficulty lay in getting the 2 cranes to achieve the perfect balance. It was over 60 meters in difference between where the cranes were installed to the tips of the vanes. The slightest imbalance from the cranes would be compounded dozens of times in the sway of the vanes. The completion of this task required balance needed to walk a tightrope across 2 cliffs. The weather, unfortunately, worsened. In the afternoon, the wind grew stronger. The task must be sped up. It was time to put the crane operator's skill to the test. There was no room for any collision. Mr. Chu was very satisfied with today's work progress. Faced with the over 128-meter diameter wind rotor, everyone was extremely cautious. However, the scene everyone feared finally happened. Luckily, the crane operators reacted timely, saving everyone's efforts from going to waste. After the false alarm, the real trouble came. The wind grew even stronger and soon exceeded the limit for proceeding. All installation work was forced to a halt. Based on past experience, unexpected wind like this shouldn't last long, and installation should continue the next day. However, a new situation came up. News from the meteorology department stated that the atmospheric pressure in the entire West Pacific region was highly unstable and would likely develop into a tropical storm or even a typhoon. The first option was to stop installation entirely. That was the safest way. However, according to safety regulations, the engine room and wind rotor must be returned to their original positions to be restarted when the unstable weather had passed. That meant the project would be delayed even further. The financial director would definitely be displeased, since the current daily cost was already near $100,000. The other option would be to continue installation once the wind stopped. The challenge this presented was zero room for any accidents before the typhoon hit. Mr. Chu was determined to take on the challenge and continue installation, but with a major decision, the final call rested on headquarters. By nightfall, the headquarters still hadn't made a decision. There was nothing to be done on site except to wait. The engine room was still on the temporary tower top, and this tower was far weaker than the official tower. To prevent any accidents in the night, a crane must provide support for the engine room. Tonight, Zheng's crane would run through the night. Early on the 4th of September 2011, Zheng makes a full inspection on the crane, which had run overnight on autopilot. Apart from a decrease in fuel volume, there were no problems. The wind showed no signs of letting up, and there was no decision from headquarters. In the last few years, Zheng had installed quite a number of large-scale wind turbines, but none of them could compare to the SL5000 before him. Zheng, who liked challenges, was rearing to go, but all he could do now was wait. Zheng is a man of few words, but he grew up by the sea and knew more about it than most people. His catch today was better than usual, which meant better food for everyone. Just before lunch, orders came from headquarters to continue installation, but would the wind die down in time? At low tide that afternoon, the wind miraculously weakened. Mr. Chu decided to seize this window of time to start hoisting the wind rotor. Jung's real concern regarding today's installation was the screws connecting the rotor and the engine room. There are a total of 108 of these arm-thick screws. The challenge in this hoist was to insert the 108 screws on the rotor into the screw holes drilled beforehand in the engine room simultaneously, 80 meters in the air. At over 80 meters high, the wind just has to be a level or two higher than on land for the gigantic wind rotor to deviate unexpectedly. Could Jung win this challenge? Sea wind would gradually strengthen in the evening. The hoist must start quickly. However, there was a problem to be solved before the hardest step of the installation. That was how to pull the biggest wind rotor in the world upright from its prone position. The solution was to use 2 cranes to lift the wind rotor to a certain height. Then one of the cranes would slowly release the rotor so that it would become upright naturally. This may sound simple, but there was no room for error in any step. At 3 p.m., the last installation process on land commenced. "45 minutes later, the wind rotor was raised to the preset height. One of the cranes backed out, and the rotor hung upright. The most gripping step of the installation began. The swing of an object is the hardest to predict in a hanging state. However, the wind rotor absolutely must not collide with the engine room, because such collision could result in serious damage invisible to the naked eye. And such hidden damage could be a serious threat to the survival of the wind turbine. The consequences would be unimaginable. The further away the remote control was, the longer would the reaction take. One command from Jung to move forward would only materialize in the rotor a few seconds later. Jung must manage this lapse in time. An hour of precise adjustment process, Jung displayed outstanding skills in control. The giant wind rotor was safely connected to the engine room before dark. Jung had good reason to be secretly delighted for a good while. In the dusk, the sea giant SL-5000 stood in front of mankind for the first time ever. To this point, everything was still within control. On the 5th of September 2011, the sea giant SL-5000 was already locked in place on the semi-submersible. At 9 a.m., the semi-submersible sailed out of the port with the help of several towboats. It was almost 40 nautical miles from the port to the installation site. The SL-5000 arrived at the site just before dark. After traveling for 8 hours on the sea, the SL-5000 reached its designated position to meet up with the Feng Fan, which had been waiting there for 9 days. On the West Pacific, the 13th typhoon of 2011, Noru, had already taken form for 2 days. The water there was already starting to look murky. There were only 24 hours left in the final stretch of this window of opportunity. September 6th, 2011. It could be the last sunny day for almost a week. The installation team would spend the entire day facing the most gripping moment in the entire project. 2 years worth of hard work, success or failure, all hinged on this final step. Compared to the sturdy base on land, the SL-5000's offshore base would move more easily due to collision. Any slight displacement of the base would become a major discrepancy at the top of the 150-meter-high wind turbine. Today, if the offshore base was accidentally hit by the SL-5000 and displaced, the entire installation process would be deemed a failure. The status of the base was monitored strictly by special equipment. The SL-5000 mustn't collide with the base. The problem was, on the rolling sea, the ship would be moving every moment. Placing the SL-5000 gently on the base seemed like an impossible mission. At 10 a.m., the workers retracted the hangar. The Feng Fan steadily lifted the SL-5000. 2 hours later, the SL-5000 was transferred directly above the offshore base. As expected, even with the help of the enormous Feng Fan, the sway of the SL-5000 was still significant. The search for a solution naturally didn't start then. The installation department already designed a docking device beforehand that would absorb the impact of collision. Once the two parts were connected, the wind turbine would slide accurately into the designated position. It sounded perfect, but the problem was that the device hadn't been used on a wind turbine of such large scale before. Would it guarantee success? At 2 p.m., when the docking device came into contact, its effect came into play. The technology in the docking device used to prevent collision was strictly confidential, but they would soon find out whether it was effective. At 4 p.m., the tower slotted precisely into place. Monitoring results show that the base remained in place during the entire installation process. On the evening of the 6th of September 2011, the Sea Giant SL-5000 was erected firmly on the side of Donghai Bridge. It is a milestone on the West Pacific region, the symbol of a breakthrough in mankind's unprecedented application of wind power.